All right, let's talk about the properties of parallel lines. The definition of a parallel line, or a set of parallel lines, are two or more lines that are coplanar, which means that they are on the same plane and they do not intersect. The symbol for parallel lines looks like a big 11, kind of like absolute value bars with nothing in between them. It's just two straight lines. Okay, a transversal. A transversal is a line that intersects two or more coplanar lines. The lines don't necessarily have to be parallel, but for our topic of discussion and for this unit, they always are going to be parallel. So we're going to be talking about some special types of angles that are formed when a transversal intersects parallel lines. All right, so here I have two parallel lines, line L and line K, and the orange line is the transversal, and I've numbered the angles that are created 1 through 8. Those aren't angle measurements, those are just labels, all right? Let's talk about vertical angles and linear pairs. We should have already talked about those previously, but let's make sure that we know and can identify vertical angles. Remember, vertical angles are always congruent, and they lie across from each other when two lines intersect. So if I list the pairs of vertical angles, I can say angle 1 and angle 4 because they lie directly across from each other, but I can also say angle 2 and angle 3. So angle 2 and angle 3 are also vertical angles to each other. On the bottom intersection, I can say 5 and 8 are vertical angles, and I can say 7 and 6 are vertical angles. So angle 5 and angle 8 and angle 7 and angle 6. So these are all parallel to each other. 1 is congruent to 4, 2 is congruent to 3, 5 is congruent to 8, and 7 is congruent to 6. All right, let's look and make sure that we understand what linear pairs are. Linear pairs are two adjacent angles whose non-adjacent side forms a straight line, or you could say opposite rays. Linear pairs are always supplementary, and there's many linear pairs that are created by this transversal and these two parallel lines. So let's just look at some. Angle 1 and angle 2, if I add those together, they create straight line L. So those are supplementary. So angle 1 plus angle 2 equal 180 degrees. Remember, supplementary means 180 degrees. I can also say that angle 1 and angle 3 are a linear pair because they actually, if I add them together, create my transversal. So angle 1 plus angle 3 equal 180. I can also say, if I look at angle 2, well, I said angle 2 and angle 1, but I can also say angle 2 and angle 4 are a linear pair. So angle 2 plus angle 4 equal 180. And I can say angle 3 and angle 4 are a linear pair. So that's 4 pairs of linear pairs that are all right here in the first intersection. If I look at the bottom, I have the exact same relationships. 5 plus 6 equals 180, so those are a linear pair. 5 and 7 are a linear pair. 7 and 8 are a linear pair, and 8 and 6 are a linear pair. So there really are 8 total linear pairs that are created by the intersection of this transversal and the parallel lines. All right, let's look at some other specific relationships that you're going to need to make sure that you understand. The first one we're going to talk about is alternate exterior angles. They're two angles that lie outside of the parallel lines and on opposite sides of the transversal. Alternate means alternating, one on one side of the transversal, one on the other side. Exterior just means that they lie outside of my parallel lines. Now I've color coded them here. The orange angles, 1 and 8, those are on alternate sides. 1 is on the left, 8 is on the right, and they're both on the outside of my parallel lines. They're alternate exterior angles. They are congruent. My other pair of alternate exterior angles would be 2 and 7. 7 is on the left side of the transversal, 2 is on the right side of the transversal, and they're both on the outside of my parallel lines. They're alternate exterior angles. All right, so what do we need to know? Alternate exterior angles are congruent. So if I know angle 1, then I also know angle 8 because they are congruent angles. They're alternate exterior angles. If I know angle 2, I also know angle 7 because they are congruent. They're always congruent. Okay, so now that we know what alternate exterior angles are, let's look at alternate interior angles. And what does interior mean? It means they lie in between the two parallel lines, but the concept is the same. Alternate means they alternate on opposite sides of the transversal, and interior means they're on the inside of the parallel lines. So in this diagram, angle 3 and angle 6 are alternate interior angles, and angle 4 and angle 5 are alternate interior angles. Alternate interior angles, just like alternate exterior angles, they're congruent. So angle 3 and angle 6 are congruent angles. Angle 4 and angle 5 are also congruent angles. All right, let's look at some other relationships. All right, so the next one we're going to look at is same side interior, or sometimes you're going to hear this called consecutive interior angles. There are two angles that lie between the two parallel lines on the same side of the transversal. So same side meaning on the same side of the transversal, and interior meaning between the two parallel lines. So if you can see here, I have them color-coded again. The orange, 3 and 5, those are on the same side and they're on the interior. They're same side interior angles. 4 and 6 are on the same side of the transversal. They're both on the right side and they're both in between the parallel lines. So 4 and 6 are alternate or same side interior angles. What you need to make sure that you remember is that same side interior angles are supplementary. So I should be able to add angle 3 plus angle 5, and that equals 180 degrees. Angle 4 plus angle 6 also equals 180 degrees. All right, so remember, same side interior angles are supplementary. Now, let's look at same side exterior angles. Just like it sounds, same side meaning same side of the transversal, exterior meaning on the outside of the parallel lines. So I have both on the left side on the outside of the parallel lines, angle 1 and angle 7, those are same side exterior, and angle 2 and angle 8 are both on the right side, and they are both on the outside of the parallel lines, so they are same side exterior angles. What you need to make sure that you remember is that they are also supplementary. So angle 1 plus angle 7 equal 180 degrees, and angle 2 and angle 8 equal 180 degrees. All right, let's look at one last relationship that you need to make sure you're aware of, and that's corresponding angles. All right, corresponding angles basically are in the same position. They occupy the same relative position at each intersection. So if you notice, in the upper left-hand corner of my top parallel line is angle number 1. Well, in the upper left-hand corner of my bottom parallel line is angle number 5. That means that angle 5 and angle 1 correspond to each other. They're in the same relative position. I can say the same thing with angle 3 and angle 7. They're both in the bottom left-hand side, so they are corresponding angles. Angle 4 and angle 8 are both in the bottom right-hand side, so they are corresponding angles. And angle 2 and angle 6 are in the upper right-hand side, so they are corresponding angles. What do you need to make sure that you remember? Corresponding angles are congruent. Angle 1 is congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. So now we're going to have to use these definitions and solve some problems. Now, one thing that I make sure that I know before I start solving problems is basically they all fit into one of these two categories. Either the angles are congruent to each other or they are supplementary. So if I know that and I have that down, then solving problems is a lot easier. So which ones are congruent? Vertical angles are congruent, alternate exterior angles, alternate interior angles, and corresponding angles. All four of these relationships are always congruent to each other. The ones that you need to make sure that you know are supplementary are your linear pairs, your same side interior angles, and your same side exterior angles. Okay, so let's look at a few problems. All right, so I have line Q and line P, and they give us that line Q is parallel to P. That's what that means right there. Remember, that's the parallel symbol, so Q is parallel to P. So I can assume that this transversal creates those special relationships. All right, so I'm going to look at the angles that I'm working with, and I'm supposed to be solving for x. If I look at these two angles, I have to think to myself, which one of those words or angle types that we just talked about do these fall into? Well, they're not vertical angles. That would be this one and that one. No, they're not a linear pair because they aren't adjacent to each other. Well, they look like they're both in the same relative position. This one is in the upper left-hand corner. This was in the upper left-hand corner of P, and that one's in the upper left-hand corner of Q. So these are corresponding angles. Well, remember about what we know about corresponding angles. We just learned that corresponding angles are congruent. So if I want to solve for x, I can set these two equal to each other. So that's what I'm going to do. I'm going to say 6x plus 5 equals 2x plus 45, and then we need to solve for x. We're going to get the x term on one side of the equal sign, so we're going to subtract 2x from both sides. So that would give us 4x plus 5 equals, that's going to cancel out, so we're just going to be left with 45. And then we're going to subtract 5 from both sides. Well, that'll cancel out. That leaves us with 4x equals 40. And if I divide both sides by 4, I get that x equals, cancel out, x will equal 10. All right? And of course, if they ask me the measure of the angles, I should be able to substitute 10 back into both of these. If I do it into the top one, 6 times 10 is 60, plus 5 is 65. If I do it into the bottom one, 2 times 10 is 20, 20 plus 45 is also 65. See, they have the same measurement. All right, let's look at one more example. All right, so in this example, the first thing you need to do is figure out what relationship these two angles have to each other. All right, I'm working with these two angles right here. Well, they're both on the inside of the parallel lines, and they're both on the same side of the transversal. So that falls into my same side interior angle theorem. All right, so if I remember same side interior angles, they are supplementary. So these two have to equal 180. So if I want to solve for x, I'm going to set up 6x plus 5 plus 2x plus 15 equals 180. So the one angle plus the other angle equals 180. And then we're going to combine like terms, and let's solve for our x. So 6x plus 2x is 8x. And 5 plus 15 is 20. And that equals 180. And then subtract 20 from both sides. So you get 8x equals 160. And then divide both sides by 8. And you get x equals 20. So x equals 20.